1, 2, and 2. All right. Hi, everyone. I think we can get started now. Thanks for coming and see me talking about AIs. I wish I had an AI come here today to talk about it, but we're not here yet. The slide was made by an AI, though, so we have that. If you don't know me, I'm Crypto David W on Twitter. If you're not following me, you should follow me so I can get more followers. I wrote this book called Real World Cryptography. You should also buy it so I can pay for my rent. And these days, I work at zkSecurity, where we do audits and dev and research. And so if you're interested in these kind of things for zk and MPC, FHE, these days TEs and stuff, then reach out to us and we'll work with you. Cool. Anyway, I don't have too much time, but I wanted to put things in perspective. So we started the company 2 years ago, almost 2 years ago. And then it was almost when ChatGPT was released, the first version. So we were starting to see AIs. And we're like, okay, these AIs they seem pretty useful, but not yet. They're kind of hallucinating a lot. We're not really using them yet. And so we're not thinking too much about it. Fast forward to today, a lot has happened. So 01 came out, 03 and 04 came out. We all know that AI has made crazy progresses. If you're a dev or if you're doing research or if you're an auditor, you're probably using AI in your day-to-day job. If you're not, you're probably missing out. And today we can say that AI has impacted the way we worked a lot. And so, yeah, I started thinking, oh my God, we created this company 2 years ago. Are we gonna get replaced? And thankfully, there's this guy that came in a leather jacket, and he said, it's not AI that's gonna take your job. It's actually the person who uses AI that's gonna take your job. So that's not comforting. I was like, all right, I just gotta use AI. And so, yeah. And so I started working on this tool. And the first target that I used the tool for, or I started experimenting with, was Circum. I don't know if you can read that, but this is what Circum looks like. It's a programming language for zk circuits. And so I thought that was a good target because we're auditing a lot of these. People are using that to write zero-knowledge proofs. A lot of that on Ethereum. Actually, most of the Ethereum zero-knowledge proof application use Circum on the L1, at least that we know of. And so we were thinking these kind of things are pretty low level. It's pretty hard. There's a lot of cryptography involved in what is written in these circuits. So if we can do a good job there, it's pretty easy to generalize. So that's how we started. Just want to mention that Claude came out, the last version of Claude came out with this report, and they sort of showed that web apps are pretty easy to solve, let's say, like if you have like challenges and bugs in web apps. But for crypto, it's not that easy. So cryptography is still, it's kind of tricky to find bugs in cryptography. So anyway, I started in a very naive way. I wrote this prompt. This is actually the first prompt I used. I managed to find it. So I started, you are one of the best security consultants on planet Earth. Like it was kind of a naive. We still don't know if this kind of prompt works better. But not really. Some people say you shouldn't be polite and you should be kind of aggressive with the agent or the AI. And so I don't know. People are doing different type of things, but anyway, this is how we started. If you don't know, all of these colors are the tokens. So tokens are the atom of AIs. Basically, you're paying per token. That's the currency. So the more tokens, the more you're paying, and the output usually is even more expensive. So the tokens that the AI generates, you pay for that. So I started very naively. I put everything in the prompt, right? I put all the code. I said, okay, look for a bug. And this worked kind of okay. A lot of the times, the prompt, so these are the numbers today for how many tokens you can have in the prompt and the output. I just looked at the state-of-the-art like closed source models, but everybody has at least 200K tokens these days, so it's a lot of tokens that you can put in there. Circum circuits tend to be relatively small compared to bigger applications. And then Gemini in Google are really on the forefront there with like a model that has 2 million tokens. So they really have large context windows. But so so sometimes we would reach the limits of the context window, and that wasn't so great, especially for larger projects when we started generalizing that to more than CIRCOM. And so when we started using large context window, we sort of solved that sometimes. Sometimes we still reach the limits, but that solved a lot of the issues as models got better. But we also realized that the more stuff is in context, the harder, not the harder, but the more you put in context, the worse the results. Like basically there was too much stuff. And I guess, it's always hard to understand exactly how these agents work, but the idea is that if there's too much stuff, it's hard for the AI to focus on what's important. So a lot of the work that we've done, like very early on, we realized that. And a lot of the work that was done was to try and remove everything that was not relevant. And a lot of the work is really, I would say maybe 50% of the work is trying to remove what's not relevant. And also, if you remove too much, I'll talk more about that later, but you also don't get good results. So part of the work was also finding out do you have enough relevant stuff? And this could be enough relevant code, do you have enough implementations of dependencies and so on? Do you have enough documentation? Does the language model understand CIRCOM? And I'll talk more about that later. But yeah, a lot of the work is doing that. And then at the end, you're like, okay, is this enough to find bugs, right? Like we're doing all these things, we're optimizing things. Like, is this gonna be good enough for us to find bugs? That's the big questions we're gonna try to answer. So, okay, so we have a code base, and these are the problems we're trying to solve. If we don't want to put all of the stuff in the prompt, what do we do? The first thing we thought about was fine tuning. So you're taking a model and you continue to train it, and you train it on the code base that you have. The problem with fine-tuning is that you have to do that every time you start with a new model. If you want to test different models, you have to do that with different models. It's costly. You need a lot of data to make it work. So it doesn't work well all of the time. And when we were working on this tool, there's new models that would come up all the time. So to us, it didn't really make sense to fine-tune anything. We just wanted to use the best models, figure out the low-hanging fruits, figure out how we can optimize as much as we can, and at the end, once we have a good product, maybe we can, or something that's very useful, maybe we can look at fine-tuning to even further improve the results. Okay, so no fine-tuning. The next thing we looked at is to use kind of a RAG approach. If you don't know RAG, that's retrieval augmented generation. And so usually that means you're storing a bunch of your documents in a vector database, and then you're doing this kind of similarity searches. So this is converting everything into vectors and figuring out which vectors are closer to each other. I'm not going to talk about how it works, but the idea would be to take the code base and create like chunks of the different functions and constants and like whatever in the code base, and then store that in a vector database, and then we can query that vector database when we're trying to analyze one function or something like that. So this didn't give us, I mean, we sort of started with that, and then we realized, wait, we actually have all the information we need. Like if we want to audit like a template, we can already run CIRCOM, we can compile it, and we can sort of get the dependency graph and get all the implementations that we want. So quickly I realized that I didn't really need RAG, or at least it wasn't super useful at this point, and I quickly moved to static analysis and fork CIRCOM and generated a dependency graph and got all of that in a tool. So by the way, RAG is still useful, we're just not using it at this point, but if you think of applications like DeepWiki that we use a lot, that allows you to ask questions to a code base, I believe it all works thanks to RAG, so this is still something that we might use later, but yeah. Anyway, I'll talk about RAG later as well, but not in the context of the code itself. Finally, especially when we didn't look at CIRCOM, we needed a way to let an agent sort of roam around in the code base. And it's pretty easy. You just need to give it like, cat, ls, grep, these kind of tools. And then you have an agent that can just browse the code base. Oh yeah, what does it look like? I guess you give some instructions and some user prompt, like, look at this function in Circom, analyze it, look for bugs. And what the agent is just a loop. It just requests some function, then we produce the result and we give it to the agent. And then it might ask another function, and then we give the result, right? So these functions are like ls, right? It lists all the files in a folder, or it reads a file, and so on. And then at the end, it gives you a structured output, and this sort of hints to the agent what are you supposed to produce. So usually we ask for like a severity, a description of the impact if it finds a bug, reproduce, like kind of like a report that you would read from a security audit. Okay, so I guess these are sort of all the techniques that we're using to have an agent sort of go through the code base and understand what it's supposed to audit. I'm gonna talk now. So how do we reduce the context window? Like some of the work that we've done. I guess this one is more of a technicality, but MCP was kind of trendy, and so it was. We quickly moved the static analysis behind an MCP server. If you don't know MCP, it doesn't matter too much. It's just a way to have like a remote server that gives access to tools to an agent. And then we really wanted to look at these traces and what was happening. And so we created this UI to help us. And here I'm just showing you that so you can see what it looks like. You have some stuff that was happening before. Here the agent asks for the implementation of some function, and then we answer with the function implementation. You're not seeing that, but we also say this function calls these other functions, and it's called by these guys. But we give all that data to the AI. And yeah, just to mention it, as for a lot of the stuff that we're trying to solve when we started working on this tool, not a lot of things were existing before, but as we worked on that tool, open source frameworks started offering the tools that we actually implemented. So like not so long after that, OpenAI like released this trace tool, which is pretty useful to see what's happening with the agent. So you can see the agent is just like listing directories, ls, cat, it's reading something. Here it's doing a documentation search. So this is why we use RAG. If there's a lot of PDF in the project, we'll use RAG here. Anyway, I don't know if this is super useful, but there's so many frameworks, and we didn't really know which one to use. If you're working in AI, you might know a lot of them. What we ended up with is it kind of sucks to use these high-level frameworks that have a lot of abstractions and that break all the time. So what we're doing is we're getting closer to the low level. We're trying to be as low level as possible. So either we DIY, like we do things ourselves, or if we ended up doing a lot of things with the OpenAI SDK just because OpenAI, the models that they were giving us were giving us the best results. And so we kind of like went with them. This might, bite us later, but we'll see. And sometimes we're using other frameworks, like we use Llama Index, for example, for RAG, and we use frameworks just because they offer some functionality that's useful to us. But all of these frameworks are trying to lock you in. They have their own abstractions, and they're not always pleasant to use. Well, not really interesting. Another thing I can mention is that we're really there's this theme of always trying to reduce the context window, what's in the prompt. We realize that when an agent roams around the code base, it creates a lot of tokens that are not necessarily relevant. It reads files, it realizes they're not relevant, it reads other files, and so on. So we do that for a lot of tools. We move these tools behind another agent. So now an agent basically can ask questions about the code base to other agents, and these agents will use these tools and answer. And now we have a summarized answer that is only relevant for what we're looking for. I don't know, I have a diagram for that, but it's pretty much going to repeat what I'm saying. If you had a bunch of ls cat, like whatever, instead of doing that, we just ask the question and we get a result. So that's much more compact, less tokens. And under the hood, what's happening is that there's another agent that's doing that search. And here, this is where we could reintroduce RAG at some point if we wanted. RAG would pretty much be like kind of a grep if we had a vector database. But yeah, many techniques like that to basically reduce what we have in scope. And yeah, so it just mentions for RAG, we also moved it behind an agent to make it more relevant. Cool, and so I guess at this point, what we ended up with is what we call a mix of agents, probably because there's a mix of experts in LLMs. And a mix of agents really, if you think of agents as like human workers, they behave very, very similarly to human workers, except that you have as many of them as you want. They don't sleep, they don't go to the toilet, they don't eat, and you can specialize them. And so what we have is sort of something that looks like a factory floor, where you have managers, you have orchestrators, you have people that just look for bugs. And so what we have today sort of looks like that, where we have an orchestrator that will crawl the code base, create an overview of the code base that's going to be useful for this security agent. And it will then find more areas to focus on. And then we have security agents that will focus on specific parts of the code base. And then they themselves can use other agents to ask questions about the code base, ask questions about CIRCOM, some metadata with the MCP, and ask researcher agents about documents if there's PDFs and more documents in the that are relevant. And we're sort of trending towards what we call micro agents, where instead of having a security agent try to look for bugs, they will actually run other agents. And so we'll have specialized agents that look only for specific bugs. Yeah, I suspect that basically anybody who's creating tools in that space will have a design that will look like that. And the only difference will be how many of these agents, specialized agents they have, how much prompt engineering they've done, how much human assistance they have, like how much extra stuff they collected manually to improve the results. And basically all of that is the secret sauce of someone trying to create something like that. Cool, I guess I can give you also, I wanted to talk about the models and their knowledge of CIRCOM. We quickly realized that models don't understand anything about CIRCOM. Here we use distilled models, so like we were trying to be cheap and use a small version of DeepSeek. I think it's 7 billion parameters here. And doesn't understand CIRCOM, obviously. We asked a distilled version of CodeLlama, gave us some, I don't know what that is, maybe it's some Verilog, I cannot recognize that language. We asked distilled version of Mistral, it gave us some Rust. And StarCoder was the best one. It said, I don't know. And then he asked me, do you know CIRCOM? But at least he was honest, you know. So okay, we're like, okay, these models, they really don't understand anything. So we need to get a sense of what they understand. So we quickly created this evaluation framework, and we asked specific questions about CIRCOM. And the questions were like, do you know how the assert function works? I didn't write the question here, but maybe I should. For example, do you know how the assert function works? Is it dangerous? If you know CIRCOM, you know that it's dangerous because it doesn't create assertions. It doesn't create constraints. And so then we have another agent that will judge the first agent that we're trying to qualify. But that other agent knows the answer. And so they can tell us if it's a bad answer or a good answer. By the way, that technique is called LLM as a judge. And so we quickly realized that even O3 Mini, nowadays we use O4 Mini or O3, but at the time of that screenshot, we have O3 Mini. They don't really know what they're talking about, even with high reasoning. And also we realized that if you run it several times, sometimes they will get the answer right, sometimes they will get it wrong. And that's because they're not deterministic. The temperature, the temperature is supposed to tell you how deterministic they are. It seems like they always answer differently. So you can sort of like run it 100 times and sort of get an idea of how many times they get the answer right. But to us, we're like, okay, we're not going to play around. We know that they don't understand things. We're just going to give them a lot of guidance. So nowadays, we used to give them guidance on basically these things like, is assert a dangerous function to use, and so on. But nowadays, we realize that they still don't understand much about Circom, even though they're very good at working with Circom. So now we give the whole documentation of Circom. And we can use an agent to even like compress it to something more concise. So yeah, so that's sort of the lesson. It's like if you put too much stuff in the context window, you don't have great answers. But if you put too little, you also don't have great answers. So yeah, here we put a lot of guidance, but also the documentation and so on. If we had the time, what we would probably do is fine-tune these models to make them understand Circom. And actually, there's some work with Move, the Move language, where they fine-tune models to see if they work, to make them work with Move. And they got pretty good results. I don't need to talk too much about that. These are reasoning models. If you don't know reasoning models, they're just very good. They're extremely good at answering questions because they will use these. They will try to like add tokens to sort of think out loud. And by thinking out loud, I guess don't look at this too much, but by thinking out loud, my understanding is that they bring context tokens that are relevant by themselves from their training data. So it's kind of like RAG, except that the data is not external, it's in the training data, and so they're bringing tokens from there. I don't know if that makes sense, but I'm sure that makes sense for some people that have worked with AI. Okay, so here we can talk about the results. So we did this sort of UI to help us think through these results. It doesn't matter too much, but it's not really a product. It's not really a thing that you can use or anything like that. It's more like an experimentation framework that we use internally to see if it's useful. It was designed for us, like auditors, and maybe one day if it's very useful for us, we'll let developers use it. And as I said, it was initially designed for Circom, but now it's a generic framework that works with any kind of code bases. And I think that's a key point. It's also human assisted. So we spend a lot of time figuring out what to bring in contexts. So like any documentation that can be helpful, documents, specifications, and so on, that can really improve the results. We spend a lot of time looking at traces to see where agents don't fuck it up and don't really understand what they're doing. And unfortunately, most of the time that we spend is spent interpreting the results, and that's what I'm going to talk about next. And wow, there's a spider right next to me. I don't know if you guys can see that. I'm going to get away from that. So the big problem with us was that we had to. Well, okay, I'm not going to talk about false positives yet. I have 2 bullet points. The results is that we actually found legitimate minor bugs. So it's very good at finding off by ones and bugs that are very common in all sorts of languages, not just low-level circuits. We also found legitimate critical bugs, and so that's where it gets interesting. I guess I say more on that soon. Oh, more on that soon because we actually cannot talk about it yet. We actually run that on some open source projects and found some interesting things, but hopefully we can talk about it in the next days. But we also run that on tools after we did the audits, and we found some really good bugs as well. I guess I'm going to talk about that now. So from the good bugs that we found, we had some false negatives. Oh wait, what am I talking about here? Oh yeah, so okay, false negatives. So we get some bugs, but they're not bugs, right? And so here the AI makes wrong assumptions. Like sometimes it doesn't look at a function, or it pretends that this function, it knows the function and there's a return value that we're not looking at. And so we fix most of these with prompt engineering, but we still have a lot of false negatives. And I believe the best way forward now is to have an agent that can create proof of concepts. And if we don't have a proof of concept, then sort of like scratch it. We've experimented with that. It's kind of hard. Like if it's like low-level cryptography, it gets kind of lost and it cannot produce a proof of concept. But in some settings, it works really well. So we're still experimenting with that. I think this is the most promising approach. And And yeah, I think we can remove a bunch of false negatives, even if we're not very sure. I don't think anybody expects this tool to be exhaustive. If we really want to make it useful for other people than just us, I think we just need to remove as many false negatives as we can. Yeah, lots of it. Yeah, that's what I said. So it has a lot of friction right now. It takes a lot of time to triage. Even though we find bugs, it's not something we use on audits currently. But if we have a free week after an audit, we'll use it to see to keep working on that tool. But I believe we're starting to use it in interesting ways, but it's at the point where it's kind of a trade-off. It's not clear if it adds friction and it's very helpful or it's not helpful. We're at that limit. Yeah. So as I said, AI is very good at finding bugs if we are good at finding bugs. If humans are good at finding something, there's a lot of documentation about it. It tends to be very good at finding them, it turns out. For things that are, like sometimes we try to match the spec with the code, and it's very tedious to do that as a human. The AI is very good at doing that. So there's stuff that it's very good at doing. And sometimes it was pointing in the right direction, and if you investigate it, like it was a wrong bug, it was not a bug, but if you investigate it, there was a bug behind it. Or he made a wrong assumption and there was actually a bug. There was actually something where it was like, he made a wrong assumption because the documentation was saying that a large number was not factorable, but actually the large number was factorable if it was a smooth number and it had a lot of small factors. And so he actually found bugs that we had found, but he didn't think they were bugs because of other reasons. Or sometimes he was like, no, this is a minor bug, but that was actually a critical bug. Like we had like some interesting things like that. But yeah, like at the end of the day, it still requires a lot of expertise to go through these reports. I don't know where the spider went. I don't know if it's on me, but someone let me know. So I don't think these kind of tools are going to replace us anytime soon, because some of the bugs that we find either ourselves as auditors or with the tool are really tricky to understand. And so I think you're still going to need, especially if you don't have a lot of expertise in-house, you're still going to need people to go through and triage and so on. Okay, so this is interesting. I think we have pretty interesting insights since we worked a lot on these kind of things, and we're continuously working on that, about the future of these kind of tools. So as I said, AI is already improving our job. Like we're using AI to learn about the code base. We're using AI like with some agents on like how to, when you look, kind of like developers are using AI, right? Like if you're trying to understand a code base or if you're trying to understand where a function is being called, now you can sort of ask an agent to do that and they'll do it for you. It's very useful. Or even to read docs or this kind of thing, it can be very useful. As I said, I don't think it's going to replace us anytime soon. Like the kind of bugs that we find are very low level and involves a lot of math and these kind of things. And for number of bugs that we find, like the AI cannot find them. And so now we're sort of trying to figure out if we specialize agents, we can find these bugs. So that's the next time you see me talking about that, hopefully I'll be talking about that. But I think for low-stake audits, I think AI and AI tooling is probably going to replace a lot of consulting firms. So web apps is an easy one. Right now there's a lot of work in consulting security around the security of web apps. I think a lot of that is going to die, or these teams are going to shrink. Smart contract is an interesting one also. Nethermind just released a tool to look for bugs in smart contracts. I think for like a lot of these small shops that don't have too much expertise are going to die. I think a lot of the markets there and these big consultancies are going to shrink in size. I mean, smart contracts are not necessarily low stake because there might be a lot of money behind it, but the bugs are usually pretty easy to find. Like bugs are very well documented and so on. Yeah, that's what I said. Bug bounties is an interesting one also I wanted to mention. From what I heard, there's more and more reports on bug bounties platform that are basically just agents reporting things. And some people are actually using the bug bounty platforms to do a reinforcement learning. And so they just throw whatever, and then they see if it goes through the filtering stage there. But the bug bounties are now using AI agents to filter bounties. And so it's kind of like, agents talking to agents now. And so you might wonder, like, why wouldn't, if you have a bug bounty today, why wouldn't you just use an agent in-house to filter people reporting these? My guess is that most bug bounties right now are just going to become SaaS with like basically agents behind doing the filtering for you, and everybody will have their secret sauce to filter through reports. Another interesting thing to mention is that there's a lot more ethics talk these days. So I'm used to ethics in physics. After the bomb was released, there was a lot of talk about ethics in physics. So that's pretty old. And in cryptography, there's some talks about ethics also, notably with Rugaway and this kind of DJB and these kind of people. And now we're saying all the AI papers that I'm reading about finding bugs with AI have an ethic section now. And it's actually quite scary when you think of finding bug with AI. I think there's going to be a lot of, we're making finding bugs very accessible for people. So script kiddies are going to use these tools and potentially exploit smart contracts. But at the same time, developers have access to these tools, and maybe they'll make things more secure. So it's very interesting to see what's going to happen. Okay, so I went fast, but I think I'm on time, so that's good. Again, I'm CryptoDavidW on Twitter, and if you want to talk to me, I also work at zkSecurity. Part of the team is here as well, so you can ask them questions as well. Yeah, thanks. Do I have time for questions, or yeah? Question here.
Thanks. Have you tried to play with like Gemini CLI or Cloud Code, and if so, what are the results, and how different is it from the tool that you show?
I mean, we work directly with the models usually. These actually, I don't know too much about Gemini CLI, but I imagine it's like OpenAI Codex or these kind of tools, or yeah. So I mean, at the end of the day, we're basically rebuilding these tools, like talking to the models directly. And when we're testing things, OpenAI was sort of the best. We're getting the best results there, so we kind of kept at it. But it's very easy to change models. So basically, there's nothing that prevents us from like testing another model, seeing if it works better, and just moving to the other model. Yeah. Other question? Maybe here.
Thank you for the talk. So my impression is that when the code base is really big, it will be really hard for the models to have all the context, as you said. So did you have, I don't know, an example of a big code base that was really hard to audit with these agents?
Yeah, I can give examples per se, but we looked at some pretty big code base, and that's why the architecture is basically one orchestrator browsing the code base, creating a summary of like useful facts, and spinning up new agents that only focus on one part of the code base. And then with that technique I talked about, where they can just ask questions to another agent to look at the code base, we're making them really focused, and then we're making their the prompt very small by using other agents that will do searches on the code base for them or in documents for them and so on. So that's probably the best answer I can give, and this works pretty well, or at least we find stuff this way. It seems to be useful. I don't know how exhaustive it is, obviously, but I mean, I'm convinced that as things are going to get better and better, these tools are going to be even more useful. Yeah. Cool. I think this is it. Thanks so much again, and yeah.